So this method, but revolving around the y-axis. Y-axis. So if I start with just a normal graph, and let's start with a parabola. Something like so. And I need a vertical bound, so let's call it C and D. Like so. So I only need this bound right there. So I'm going to erase all the graphs that I don't need the bounds for. We're just going to draw the picture. I'm going to rotate this around my y-axis now. Around this guy. So I'm going to draw the same thing roughly on the other side. And we're spinning it around. So now I'm making it 3D. And we have, that was our beginning area. And we want the whole volume of this function, of this revolved solid. Same thing we did for our axis, except now our cylinder is more like right here that we're taking. All the way around. So this is what we want. Is this going to be our dx or a dy? Dy, yep, because we're all around the y-axis. So dy, we have a balance from C to D. And what should be inside? Yep, we have a dy. I need my function too. Yep. And what do we have to do to f of y? Yep. Is that it? Pi. And I would always recommend writing it inside for right now so we don't forget pi. Just like a volume formula, we need our pi. Okay, that is a volume. Let's do an example. Let's take y equals ln of x. And we'll revolve it around the y-axis and have a bound at y equals 2. You don't need to look at what this graph looks like. You know what this graph looks like. Who can remember what the graph of ln of x looks like? Show me with your hands. It's a log function. What does a log function kind of look like? Think about what quadrants you're in for logs. When we're not shifting it left or right, or up or down, really. JJ, what quadrants are you in right now? Okay, I think you're more in an exponential graph, sort of. Wait, take an L hand, L for log, flip it upside down. Boom, that's your log graph. This is your asymptote, you're gonna go up and you're curving. Yeah? Okay, log graph. Look something like, well, it's log of E. It's a little shift, but it's gonna look something like that. That is your ln of x graph. Now you don't always have to graph these. You don't actually ever have to graph these if you don't want to. But it's gonna help you. Now my bound, since I'm doing it around the y-axis, do you want to draw it or no? Yeah? Okay, let's draw it. You guys draw it first. Going from 2 to 0. Sure. Yeah, that's fine. Oh, it's like Christmas right now on the sheet. I didn't mean to do that. Yeah. It's so much better on the paper.
Yours are really good on the paper, but these will be even better. So I just put it here, and then like when we're doing this, it'll take a second to load. But what's really cool about this one? Oh my gosh! If we do it, and then we only do it for.
Oh.
So well, like I'll show you because it's gonna get weird.
Yeah.
0 to 2, right?
0, yeah, 0, 2.
So what I do when I'm doing this one is I'll turn the axes so that they make sense for the kids first. So here is the graph of ln x, and then whenever you're playing with this, when we do this, it'll turn it, and then you can see actually like we can turn the whole thing and see the three-dimensional figure that it forms. But I would start there,
yeah,
just to show ln x, because it's just x and y, and z's right out towards us. There you go.
Yeah.
I'm not gonna resume that until.
Oh, that is so cool. Oh no. Wait, back. Okay, did we sketch it? Okay, want to see this cool thing for sketching? Okay, that's our graph. Wait. This is the area of it. And if I keep rotating it all around, so halfway almost, and I keep going around the other way. So that's a version of the graph. Do you have this drawing in it? So this is where I would do like those round things, and I'd put another round one right about there, maybe. Yeah. And down below. Cool. 3D shape. Something like that. We got it down below, and we got it above at 2. Do you guys start writing the integral? Yeah? Okay, what was the integral? V equals our bound pi, a function squared of dy. Okay, let's fill it in. What's my bounds? Yep, and what is my function? Ooh, close. We want it in terms of y. So I have y. How do I get that in terms of y? Yes. X equals e to the y. So I'm just changing it into an exponential. So I have e to the y. Up top. Little reminder. I have y as a power to another power of 2. What happens to our powers? Yes, we multiply our powers. So now I can take pi out. I promise you might forget in the future. So e of 2y of dy. Okay, do the integral. Okay, what's my next step here? What happens to the exponent? So the e to the 2y will stay the same. I have a fraction out front. What's my fraction? 1/2. Yeah, why is it 1/2? Yep, exponent just, you flip it. It becomes a fraction out front. Yep. So that's what we have, from 2 to 0. Okay, I'm just going to take out the 2 to out front. So I have pi halves out front. Then I have e to the 4 minus e to the 0. What is anything to the 0 power? 1. So if I had like x to the 2/3, what would I have to do? I was doing like the antiderivative of it. You flip it, right? Yeah, this should be a 5. So it's the same thing's happening, except you don't do anything to the exponent. You just flip it out front. Okay, so e to the 4th is a number. I don't know the number off the top of my head, but this is -1. E to the 4th. Yeah. 1, 2, 3 to the 4th. I'm going to put in so I took out the 1/2 because it's just a number. So coefficient goes out front. And then put in a 2. So let me do over here. So I have pi over 2. And I have e to the 2 times 2. So I'm just plugging in for y. Minus e to the 2 times 0. Yep. And what is e to the 4th roughly? 54. Give me like 2 decimals. 0.6? Right, 0.6. Minus 1. Minus 1.
The standard for rounding, just a heads up, is 3 decimals if it's not stated. I always thought it was 4. AP College Board says exactly 3 if it's not stated, but you should round if you're going to approximate.
Okay, let's go to 3. 598. Nope, that's not eraser. 598 minus 1. That should equal. Alex, what did you get? Negative? We got a very large number, minus 1. So now I have pi halves 53.598, which should equal 84. Keep going. 191. Okay. And what is my units? Talk about volume. Yep, units cubed. I like that you guys do u something instead of writing it all out. So much faster. Okay, any questions? No? Do we want to do the board? Sure. I'll find a problem. Get into any groups you want. Any groups you want.
If you don't have one, push return. Any of my notes don't have one. You have mine. If not, I can grab one. Yeah, that works too. If you want one, then you can use either of those. Hey, we're doing the same thing.
Okay, I'm going to be nice and I'm already going to put it in terms of y for you. X, revolve this one around the y-axis. I would not recommend graphing it. Yeah. Does it not look like it?
No, I'm good with it. I was thinking of that, kind of thinking what the shape would look like.
It's a parabola. Yeah. It's the answer.
It should be there. But
No, it is.
sometimes I'll write it and then I won't put the answer because I forget or What's the circle's area? Pi times what? R squared. One.
We talked about it yesterday.
What's that?
We talked about it yesterday.
No, I
Yeah. We gotta go on to washers. Let's draw our nice washers. Washer method. Oh, okay. Also, when I see a washer, I don't think of a washer. I think of a CD. That's true. No. They're right there. Yeah. Okay. So we have our two functions. Well, let's just do a straight line. Let's do two straight lines to start. We're going from A to B. So this is A. This is B. And we're going to have two. Because remember what we did at the beginning of this? We were trying to find the area between two curves. So right now we have two curves. Let's just make them straight for now. So normally we would find the area in between these two curves. So all of this mumbo jumbo right here. But now we're going to talk about volume. We're talking about washer. So we're going to rotate this. Let's draw it with the x-axis. Rotate this all the way around the x-axis. So my way of doing it, I'm just going to draw the same graph at the same height down below, roughly. So about right there. Ooh, that was not a straight line. Down below, and I also need my second graph reflected over the x-axis down below. And of course, we're evolving this, so we're making it a solid. What color should I pick? I'm going to go with red, a dark red. So I'm connecting my two lines that we reflected and the outer ones as well. So we're doing the same thing as before, except now we have two things that we have to revolve around the x-axis. Right there and behind. So we have a cylinder, and there's another smaller cylinder inside of it. But that's a hole. We're not talking about that area. We're only talking about kind of like all of this area underneath here. I'm going to ruin this picture. And all of this area, not the middle part of the washer. Okay, did that confuse you when I just drew all that squiggles? Really? Okay. Confused me, but okay. So 3D shape now. We have a cylinder. and we have a hole right in the middle of our cylinder. It's just combining two different formulas you've already seen into one. Do you want to do it now? We'll do this one with the easy one. Okay, you know how to do the volume of the big one, right? Large cylinder. Large cylinder. You know how to find that, right? Yeah? What is it? Yeah. Of dx, right? So this would be the f of x. Let me choose a different color. Writing this. So this is the f of x. This is the top one. What should we call the bottom one? G of x. Yeah. So the volume of the inside of that one is the same thing, except we're talking about g of x. Dx. Sorry, this should have been x up here. So just like the area between the curves, what do we have to do to the large cylinder and the small cylinder? Yep, subtract them. Cylinder. So then our final result is down here in red. So we have volume equals, we're only gonna have one pi here, just pi. Now you can put it on the outside because it's gonna be a little funky if you put it inside. Of AB. Which one should go first? Large or small? Large goes first. Yep. Of f of x squared minus g of x also squared. And dx at the end because we're going around the x-axis. Not that hard, right? Is it better than you thought or harder than you thought? Yeah. We did it with an easy image for these. So if I had my cylinders that we're doing the dx of, so we're cutting it, we have this guy. So we're cutting into a whole bunch of tiny little cylinders. Then we have the inside portion. Boom, boom, boom. So it's going all the way around. But we also have, that's the large one. Then we also have the small one inside as well. Wow, this is not coming out as pretty as it could. Okay, but we got the small one inside as well. So we need to subtract the small one from the large one. That's all we have to do. Should be easy. Okay, we only have 4 minutes left. I'm trying to think. Do you want a washer problem to do, or do you want homework from DISC? Okay, DISC it is. Okay, we'll talk about this one more. So homework. What section have we been in? 6.2? Okay, page 486. 24 was a washer, which we talked about, so we're not going to do 24. Let's do, I'm now just picking them random size, so 25, 29, and 31. I'm going to see if any of them are. They might change, FYI. We'll do 26 also. 26 too. If one of them is a washout, try it. But if it's hard, it's okay.